Okay, so we said that sometimes we need to overload the assignment operator, and then we showed you an example where we didn't actually have to overload the assignment operator. Things still worked, right? If you have three objects, x, y, and z, that are all instances of the ABC class, you can actually have this work. You can have the assignment operator work. And it actually does exactly the right thing. Oops. All right, fix this. All right, this thing does work, and it works the same way that ints work. It goes from right to left, assigns x to y. This whole thing has the value y, assigns y to z. All right, and you quote x operation. Okay, so it works, and then I said that, well, when we overload the assignment operator, then we have to be careful how we do this, and also that's when we overload the assignment operator, that's a situation where we can use the this pointer, and that comes in handy. Well, you might say, well, why do we need to overload the assignment operator? Because it works. Well, we'll get to that in just a second. Okay, so we'll look at a case, very simple case, where you would need to overload the assignment operator, and you would not want the default behavior. Before we do that, let's just remember a few things. Recall that the assignment operator in a class must be a member of the class. So I actually just said that the assignment operator has similarities with the insertion operator. Well, here's the situation. Here's the well, it is similar, but it's also unlike the insertion operator in that it has to be a member operator. The way insertion works, it has to be a standalone function. It can be a friend function that just gives you access to private data members, but doesn't have to be a friend function. That's only for efficiency. But however, the way insertion works, to allow this chaining of insertion operators, you have to have this be you have to have it be a standalone function. It just doesn't work any other way. On the other hand, assignment has to be a member function. All right, my recording is having problems. Sorry about that. Okay. So the assignment operator, unlike insertion, must be a member of the class. It has one parameter that is the right-hand side. So when you say s1 equals s2, think of it as s1 dot and use the member operator assignment or equal, and then you only have one parameter. So this is sort of like a member function operator that is the, let's say, the plus operator or the minus operator. Okay. Now we want to be able to do this. We want to be able to chain assignments. But we also want to be able to do something like this. We can say we should be able to do this, put parentheses around the first assignment and then assign S3. Now on the surface it doesn't really make sense, because in effect what we're doing is we're assigning everything in S2 to S1 temporarily, and then this thing, the value of this whole thing is S1, so we're assigning the value in S3 into S1. So sort of doesn't make sense, but I'll just tell you that there are situations where this might come in handy, and so yeah, we still do want to have this work. Okay, to have this work, we have to have this whole thing return an object of type S1. Okay, whatever that S1, and actually we should just return S1, and then pass that to this operator, so that what we do is we do this assignment. The value of this whole thing in parentheses is S1 effectively, and so that we can do S1 equals S3. Okay, so keep those things in mind, and this is what the assignment operator would look like. And this is an example class, so a class called string class. Okay, it takes this is a member operator. You can see that from here. This is the scope resolution operator for the string class. It has a member operator, that's assignment. It has one parameter, which is a const, and which is the right side of the assignment operator. And then you do actually have to do this check, although a lot of people skip it. You check if this is equal to the right side. Why are you doing this? This would be to avoid a lot of problems with, let's say, for whatever reason, you end up with an assignment like A equals A, right? If you are going to do that, the right side is the same as the left side, and you should just return this object itself. In Java, we would just return this. Here, we would return this dereferenced because this is a pointer. Okay, and what we're returning is a reference. So we need to return star this, and this is what we meant by saying that this pointer is extremely useful when we overload the equals operator. Now, I haven't really talked about why we would need to overload the assignment operator, because it sure looks like it works right now in the simple example we set up. But I will set up another example where it doesn't work, and then we will see that we definitely do need it. Okay. After this, after you check if the left and right hand side of the assignment is the same, and if it is, you just return one of them. It doesn't matter which one actually, and just return star this. If it's not the same, then what you want to do is just copy all of the things over from the right hand side, so you get the length. We're just assuming that there is a data member called length. You assign that to capacity, and then we copy it also over to this arrow length. And like in Java, you don't have to say this. Then we can delete the current array that's in this. So we're deleting the open close square bracket, this arrow A, and we don't need this arrow, so we just say A. Create a brand new array, and then copy everything over from the array on the right hand side into this array. And then when you're all done, you just return. You dereference this, that is, you get the object and you return an object of type string class. Okay, so this is what you need for the assignment operator to work. To see why we need an assignment operator, we have to look at shallow versus deep copies, and that's the thing that I'm going to look at next. So what I'm going to do is give you an example of how shallow and deep copy works. Now, it turns out the default behavior, if you use objects and you do something like this, it copies. The default behavior is to copy the contents over. If you have an array, turns out it does the right thing. Here's where it does not work exactly as we would expect it to work. Okay, so if you had, instead of a static array, that is not dynamic array, but instead you had used pointers, okay, and you did, instead of doing this, you allocate memory inside the constructor, which is actually pretty normal behavior. New int, and let's say we always allocate a fixed size of 5. And that's not always true, right? You might, for some instances of the base class, you might want to allocate more or less. Let's say for now, to keep it simple, that we, instead of having it be a non-dynamic array, we make it a dynamic array. We allocate memory from the heap. Okay, and then everything else stays the same. That's fine. Now, let's run this. Let's compile it. Everything should compile, I believe. Eventually. Okay, there goes. It's building. All right, compiled. And it is running. There, good. Everything worked. And now what I want to do is I have set up this function for just this purpose. I set up a getX function, which is a const function that it says it's promising not to change any data members. That's actually what it's supposed to do. But here's the thing, it does something sneaky, that is it returns a pointer to a data member that's inside this. Now this is something you never want to do. This is just for debugging, alright? So I'm only doing this so that I can print out the location of this array. Now we did this with a case where we didn't have a dynamic array, we had a statically allocated array, and there we saw that the assignment function did the right thing. That is, it copied the contents of the array over from x to y and then from y to z. Now let's see if we use dynamic arrays. Well, does it do the right thing? Let's compile this. Should compile. So all I did was I made x a dynamic array. It worked. Everything worked like before. Now what I'm going to do is I'm going to print out the actual address of this data member. And that C++ allows us to do this. That's why we're taking advantage. And here we see something very disturbing. That is, notice that in x, the array has something, 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 C0, y has something different initially, and z has something different. Now, after we do this x equals y, and then this whole thing has a value y equals z, what we see is that they all three have the same location for their arrays. In effect, what we've done is we've copied this x, the address that is in x, which points to some location in the heap. We've copied that over from x to y, and then from y to z. So now x, y, and z are three objects in which they all point to the same internal data member, which is very bad. Mainly because if you change z, now x changes, even though z doesn't change. So this is different from, you can back up and try this out yourself. Switch this back to being not a dynamic array but a static array and print out the addresses. They will be different before and after this chain of assignments. However, in this case, when you use, all we did was really change just one thing. That is, we made this a dynamic array, and now actually things are not really working as they're supposed to be. And you can try this out for yourself. This is a pretty serious bug. It's very hard to debug situations like this. And this is called a shallow copy. So that's what's in the notes. A shallow copy says that when you do an assignment, it copies only the member variable contents over. It doesn't make the contents of the array, just the contents of the member variables themselves. And if you have a member variable that is a pointer, then you're out of luck, because what it's going to do is just copy that address over into each one, so that now x, y, and z all point to the same object as their member variable. And that's not a good situation, because you don't want that to happen. You want to have those objects be completely separate. What you want is a deep copy. That is, if you want everything in, if you have pointers and dynamic memory involved, which is what we just saw, we have to get to the data that's in the source and then make sure that you can copy it over to the destination. And so make sure there's enough memory in the destination and then copy those things over. So that's where you would have to write your own assignment operator overloader. You have to overload the assignment operator and then copy the constructor and copy constructor in this case. So this is what this is doing. So what we want to do is this kind of thing where we delete the old member variable, which is an array, create a new one, and copy it from the right hand side. Okay, and we'll do that in the next step.